Alright, we've already kind of hinted at this, but I wanted to have a formal video on particular solutions. So if you want to find a particular solution with an initial condition, first you want to go ahead and take the antiderivative, use the integration to find the antiderivative, that's the capital F of x. And then we're going to solve for c. We're going to solve by c by plugging in the coordinate that they gave us, our x coordinate, y coordinate, and then solve for c. Finally, once you have your c, you're going to plug it back into your original equation, and depending on the situation, when we get into differential equations, which is after spring break, we're going to actually solve for y. But at this point, we don't really need to worry about it. We can just go ahead and take the antiderivative. Alright, number 1, find the particular solution of y if the derivative is equal to 3x squared minus 1, and it's passing through the point 2, 4. And so we can just go ahead and take our antiderivative. So our y is going to be equal to the antiderivative of 3x squared minus 1 dx, which is, if I take the antiderivative, I'm going to get 3x to the third over 3 minus x plus my constant. As you notice, your 3's are going to cancel. And so if I want to solve for this c, then I need to plug in my point. And my point is 2, 4. So if y is equal to 4, and x is equal to 2, then I get 4 is equal to 8 minus 2, which is 6. So 4 is equal to 8 minus 2 plus c. And so 4 is equal to 6 plus c. That means c has to be negative 2. Well, just because I solved for c, I can't just leave in this form. They want me to put it all together. And so my form is y is equal to x to the third minus x minus 2. Alright, number 2, find the particular solution of f prime of x is equal to 3 over x to the fourth, where it's such that x is greater than 0, and passes through the point 1, 2. So again, this right here is going to be our coordinate that we're going to be passing through. So our first job is to find the original equation. So f of x, the antiderivative, is equal to, I'm going to go ahead and fix this right here, that x to the fourth, and move it up, and so it'll be x to the negative fourth dx. And I'm going to go ahead and take the antiderivative. That leaves me with 3x to the negative 3 over negative 3 plus my c. And you'll notice that my 3's are going to cancel, and I'm left with x negative x to the negative 3 plus c. And because my exponent is negative, that means he's from the denominator. So in order to plug my point in a way that I would understand, I'm going to go ahead and fix it. And so I have a negative, my coefficient is negative 1. There's negative over, and I'm going to go ahead and move my x to the denominator. So it becomes x to the third plus c. And that sets me up pretty nicely in order to plug in my coordinate. Well, my x coordinate is 1, my y coordinate is 2, so I'm going to be plugging in 2 is equal to negative 1 over 1 to the third plus c. And if I was going to simplify that, I'm going to get 2 is equal to negative 1 plus c. That means c has to be 3. And again, I just can't leave it like this. I want me to put it all back together again without the plus c. So I'm going to take this equation and go ahead and plug in my c, which is 3. And so I get f prime of x, or excuse me, f of x, not prime, is equal to negative 1 over 3 plus 3. Number 3, the acceleration of a particle moving along the x-axis at time t is given by a of t. The acceleration is a of t is equal to 6t minus 2. If the velocity is 25 when t is equal to 3, that's my first point. So this will be my y coordinate, this is my x coordinate if you want to think about it that way. and the position is 10. Again, this will for my position function, that'll be my y coordinate, and this nt is 1 is my x coordinate. Then what is the equation of the position function? Well, if they gave me the acceleration, the antiderivative acceleration is velocity, and the antiderivative of velocity is the position function. So I have to take the antiderivative twice and solve for c twice. So let's first find our v of t. And that's going to be equal to the antiderivative of your acceleration function, which is 6t minus 2. And so that's going to give me t squared, 3t squared minus 2t plus c. And the information it gave me was, again, 25 is my y coordinate, and 3 is my t, so I can solve for c using those. So I can say 25 is equal to 3 times 3 cubed. Again, I got that from the information above. If my velocity is 25, that's the y coordinate, and my t is to the third, or is 3. Sorry, I wrote to the third. It's supposed to be squared. Sorry about that. And then minus 2 times 3 plus c. And so now I can solve for c. And so I have 25 is equal to 27 minus 6 plus c. Well, that gives me, this right here will give me 21. And so c has to be, let's see here, 4. And so my velocity, my v of t, is equal to 3t squared minus 2t plus 4. And so I'm going to use this function, take the antiderivative of it again to find my position function. And so to find my, we'll do x of t. And that's going to be the antiderivative of your velocity. I'll keep it color coordinated. Which is the antiderivative of that 3t squared minus 2t plus 4. That whole thing is multiplied by dt. And so I'm going to take the antiderivative of that guy. And so that leaves me with t to the third minus t squared plus 4t plus c. And that is equal to my position function x of t. And so I can now plug in. And again, I said the position is 10, so that means I'm going to be plugging in 10 into the y coordinate is equal to, and then when t is 1, so we're plugging in 1. So 1 to the third is 1, minus 1 squared, which is 1, plus 4 times 1, which is 4, plus c. These guys are going to cancel, so I'm going to get c is equal to 6. And so my final x of t is going to be t to the third minus t squared plus 4t plus 6. And that is my final position function.